Hi, my name is Vaishak Prathap. I am a PhD student in the Department of Electrical Engineering at University of Buffalo State University of New York. I'm doing PhD in the field of analog mixed signal IC design under the able guidance of Dr. Albert H. Titus, who is the chair and professor of Department of Biomedical Engineering at UB. In the IEEE Census 2021 conference, we are presenting a novel architecture for an on-chip pH sensor with substrate-based drift reset capability. Let me give you an overview of our work. There are fluids within our body such as blood, saliva, sweat, and urine. Each of these body fluids have nominal pH values. If the pH levels of these body fluids fall outside their nominal ranges, then they are indicators of medical problems. The fast, low power sensing of pH is an important component in the detection of diseases. A measurement device which measures the pH change in human fluid samples must have certain qualities, like they should be very small in size, they should be very highly sensitive, they should have very fast, rapid response, they should be robust in the sense that they should not be easily damaged when exposed to stressful conditions, and also they should be able to collect and transmit data in real time. The existing pH sensing methods are mostly optical, which are dye-based and fluorescent-based methods, but these methods have the disadvantages that they are bulky, they are fragile because they mostly use glass-based materials, they have slow response, and they use some kind of labels for detecting pH. The solution is to go for solid-state sensing methods. That brings us to ion-sensitive field effect transistors, short-termed as ISFETs. Ion-sensitive field effect transistor is a solid-state electrochemical sensor. The ISFET is similar to a MOSFET in the sense that they have source, drain, gate, and bulk terminals. The gate of the ISFET is taken up via the stacked metal vias to the passivation layer on top of the chip. The passivation layer on top of a chip, usually in the unmodified CMOS process, is the silicon nitride layer, which is inherently sensitive towards pH. So if we put a solution on top of the chip and define the potential of the solution using a reference electrode, then the passivation layer develops a potential proportional to the pH, and this potential will in turn change the threshold voltage of the ISFET device. The threshold voltage change of the ISFET device can be extracted using suitable on-chip circuitry. This is the basic working of this is how basically ISFET-based pH sensing works. There are 4 common non-idealities which corrupt the ISFET readout. They are drift, offset, due to trap charge, temperature, and chemical and electrical noise. Most of the schemes reported in literature to compensate for these require complex characterization and implementation and make the sensor system occupy larger footprint by introducing additional circuitry. We present a novel ISFET-based pH sensing architecture which is able to compensate for all the non-ideal effects mentioned previously without any complex software or hardware-based compensation schemes, and occupy only a very small footprint. Also, we demonstrate within our chip the ability to reset any residual drift or offset present with the help of a control voltage knob. To know more about the operation of our circuit and to see the experimental results, please visit us on Monday, November 1 between 1:30 and 2:30 p.m. in IEEE Census 2021 conference. Thank you.